Okay, well, hello and welcome to everyone who's joined us this morning for the Bow Valley Sustainable Building Summit. My name is Jody Connuel and I'm a program associate at the Biosphere Institute of the Bow Valley, and I will be your host today. Before we get started, I just wanted to cover a few housekeeping notices. So as webinar attendees, you will not be able to unmute your microphone without permission, nor will you be able to turn on your video. However, this is a active Q&A session. So if you have any questions for Frank, please type them directly into the Q&A box that is accessible using the bar along the bottom of your screen. Frank will answer these questions as they come in. If you feel that Frank hasn't answered your question satisfactorily, please feel free to use the raise hand function available in the participant panel, and we'll allow you to turn on your microphone so you can perhaps rephrase your question or add on a follow question. If you're experiencing any technical difficulties, please email resource@biosphereinstitute.org, which I will put in the Zoom chat very shortly, or you can message me privately using the chat function, and I will do my best to troubleshoot any problems that you might have. So the Bow Valley Sustainable Building Summit has been brought to you today by the Biosphere Institute of the Bow Valley and the Bow Valley Builders and Developers Association. The Biosphere Institute is a local Canmore-based charity, and we aim to address what we believe are the two major challenges affecting the Bow Valley today, one of which is human-wildlife coexistence, and the other is climate change. Our climate action efforts are managed under the Bow Valley Shift program, where we promote local action and residents and businesses are encouraged to reduce their energy emissions, waste production, and water use. The Bow Valley Builders and Developers Association is a membership-driven networking and advocacy group. BODA keeps its members up to date on issues impacting the industry and our community, and also on municipal decisions that impact the development and construction industries. BODA luncheons, pre-COVID of course, have become the premier monthly business networking event here in the Bow Valley. With funding from Energy Efficiency Alberta and the town of Canmore, the Biosphere Institute spent 6 months in 2019 talking to local businesses and developers and construction workers to find out what they want to learn about energy efficiency and how they want to learn it. The result of this research was the Bow Valley Sustainable Building Summit. Due to the COVID-19 pandemic, the decision was made to take the event online, and that is how we got here today. So I would now like to introduce today's presenter, Frank Crawford of Passive House, Alberta. Frank is a professional civil engineer and a certified passive house designer. He designed, built, and now lives in one of the first Albertan homes built to the international passive house standard. Through his work as an energy efficient consultant and the education committee lead of Passive House Alberta, he helps others learn how to achieve the benefits of building a highly energy efficient building whilst minimizing the additional upfront costs. So that's enough for me. I'm going to hand it over to Frank. He's got a short presentation and then he's going to be answering your questions. Take it away, Frank.
Thank you, Jody. Welcome all. Thank you for your interest in energy efficiency, passive house, and high performance building. So I am part of Passive House Alberta. We are a small nonprofit foundation, and our vision is that Passive House is the standard for the built environment in Alberta, accessible and affordable to all. So we provide education and resources to help attain that vision. Jody went through most of this. I am an energy efficiency consultant, education committee lead for Passive House Alberta, civil engineer, certified passive house designer. I had about 12 years of commercial construction project management, built a LEED Platinum and LEED Gold office building, and I'm currently sitting in the Montgomery Passive House, which I built, and my family lives in, as long as with a secondary suite tenant down below. So for those that know absolutely nothing about Passive House, the international standard, basically comes down to 5 main principles: insulation, air tightness, thermal bridge free, windows and doors, and mechanical ventilation. And there's a number of free webinars and such on Passive House Alberta website and out there to do some more basic learning if you need it. But today we'll get to the questions and answers fairly soon. First, I'll just go through a bit of embodied carbon update. So embodied carbon, for those that don't know again, is basically the pre-occupancy or the upfront carbon. It's the amount of greenhouse gas emissions that are emitted in the material extraction, manufacture, and occasionally transport to site of materials. So this is an old slide. It's using 2018 information. You might have seen it before. It was in the previous talks that I gave in Canmore, and it comes from Architecture 2030. And the main things to highlight is that the high density spray foams and the XPS foam are kind of the two ones with the highest embodied carbon. But things change. We now have some new data, and you can see there's been some fairly large changes, at least in the top two. So closed cell spray foam now has a new chemical formulation. Instead of using HFCs, they're using HFOs. Don't ask me exactly what that chemical is, but this new formulation reduced their greenhouse gas emissions by about 50%. So that's a pretty big change, and good for them for making that change. And XPS, also you'll notice, has actually gone up by a fair amount. That isn't a change. It's just kind of another re-review of some product data. But again, now the XPS manufacturers realize that they are one of the higher emitters, so they are looking at changing their formula to reduce that. So spray foam still isn't perfect. It's still not a permanent air barrier unless it's continuous. Spray foam itself is an air and vapor barrier if sprayed, I believe, over 2 inches thick. But if you're spraying it between the studs, the wood studs will move and shrink and expand as the moisture in the wood changes and as the house settles. So you can't purely rely on spray foam unless it's continuous all the way around. But for example, if you're doing a renovation and you have some existing kind of difficult details and it's hard to get anything else in there, you now don't have to feel quite as bad using the new HFO spray foams. For all this embodied carbon thing, items, I'm not an expert. I just follow what other people do. Some of the people that are experts are the Embodied Carbon Network. There's a chapter in Vancouver, and they recently did a whole bunch of webinars on this. Jody will be able to put the links to all of these webinars in the chat box, so you can go and look at them. They're from both people testing the embodied carbon and also from actual industry professionals like from BASF that actually create this new HFC spray foam. So it's very well balanced carbon updates. Also, Chris Magwood is another excellent Canadian that's working on the embodied carbon areas. So in addition to insulation, concrete has a fairly large embodied carbon. So the Portland cement, which is used in most concretes, accounts for 6 to 10% of the world greenhouse gas emissions. So again, that's a fairly large number. But again, work is being done on it. Inland Concrete in the US recently has come out with a new mix that reduces their embodied carbon by 30%. For a fairly small upcharge, it's about 5% in the States. I don't know at this time if it's available in Canada, but we should start asking it because Inland does sell concrete here. And there is also a 50% embodied carbon reduction mix that's possible. Closer to home, Lafarge's Exshaw cement plant received a $10 million grant from Emissions Reduction Alberta about a year or two ago to explore diverting waste products to use to fuel, to replace natural gas for heating the plant. Because the fuel to make the boiler hot so they can actually heat up the lime to make the Portland cement is about 50% of the total concrete emissions. So I guess this is just two large industries that have moved in fairly short time period to reduce their carbon footprint as consumers demand it. So keep up the good work, keep demanding better options as you're buying products. Always look for the option that has lower embodied carbon, or at least ask the question, if you can't find it. The more people ask the questions, the more the industry will move to meet the demand. So the next little update I have is in regards to deep energy retrofits or renovations. So we're fortunate that Solar Homes, Peter Darlington from Calgary, he renovated his home to using Passive House principles, and he actually recently was given the first Canadian Home Building Association's Net Zero Home Renovation certification. So there are a number of certifications for net zero from various organizations, some for new builds, some for renovations, and also Solar Homes is one of the participants at the Biosphere's sustainable trade show, online trade show, or a symposium that you can go and look at and talk to them and other people working in the industry. So we do have the local knowledge, some information on his house, and it's kind of standard on the other houses he's done. The price for a net zero renovation is anywhere between $80,000 and $130,000, depending on what the scope of work is. Generally, the scope of work is adding about 6 inches of insulation to the outside. Peter uses Eps Foam as an EFIS product. So you add the foam or insulation to the outside, you increase the air tightness using various techniques. You add some more insulation into the attic. You can insulate below grade going down the foundation walls if you have space to excavate. Otherwise, you just want to make sure that at least you kind of cover up the rim joist of the main floor, because that's one of the larger thermal bridges, and get as far down the foundation as you can, and then you can change the insulation to the inside if you have to. You obviously put in better windows, triple pane windows. Peter just used Lux windows. They're not Passive House certified, but they are fairly high performing windows and triple pane glazing. You adjust the solar heat gain of the glass depending on the orientation and the shading. You then put on some solar panels on the roof to get some generation, that's how you get to net zero. And then you would change out all of your heating appliances and your furnace to electrify them using heat pumps, using a heat pump hot water tank and a hydronic heat pump coil that replaces your furnace. You use the existing ductwork as much as you can. You just now have that hydronic coil with a fan pushing either hot or cold air through the ducts. And then you put in an ERV to make sure you're always providing that continuous, balanced, filtered, fresh air to the house and exhausting the contaminated, stinky, smelly air from kind of the kitchens and bathrooms out. And that's how you improve the indoor air quality. So that's kind of the scope of work of a net zero renovation. You can add stuff to it as you want, or reduce it, or stage it over a few years. But that's kind of the stages that you go through. So that was it for energy retrofits. So now we'll go to some of the questions. So if you have any follow-up questions that I don't answer today, there's education@PassiveHouse Alberta. That's the email you can get me at, or it's passivehousealberta.com. So we have a few questions that were sent in before. I will go over them, and then I will just looking through the live questions. So the first one was, does external insulation with wood fiberboard work well in our climate? The answer is yes. Just about any type of exterior insulation works well in our climate. I am preferential to having a vapor open insulation, which is some types of foam. EPS foam is, XPS is not, spray foam is not, but blown cellulose is, and wood fiber definitely is. So it is a good one. Roxwool is another option. You always pick a few things, or need to look at a few things when you're picking insulation. Vapor open, R value, fire resistance, water resistance. So wood fiber does burn, but it burns very slowly. It is dense enough that as long as it's behind a cladding, it won't promote fire, but wood fiber is an excellent option. The downside is right now we are importing it from Europe. There are a few people that are attempting to open wood fiber plants in North America, one in Maine and one in Canada, but That's still a few years away. So at this point, the wood fiber is coming over from Europe. But if you're filling a container full of wood fiber, the embodied carbon to bring it here isn't that much. But yes, it does work in our climate above grade. I would not use wood fiber below grade. So moving on to the next question. How do you address waste generation and resource recovery in design and construction? So I guess the first way would be is when people come to me saying, I want to build a new house, I say, okay, great. Kind of there's three options with that. Do you actually want to build from scratch, like demolish the existing one? Or is it completely bare land that has no house? Or do you want to do a deep energy retrofit where you're reusing an existing house that's on the land? Or another option is there are house movers in Calgary and in Alberta that will move a house that isn't needed somewhere else to your land. And then you can then renovate that house on a new space. So those are kind of the best ways to reduce the waste generation. The other option would be you use prefabrication or modularization or panelization, where portions, either all or a portion of the house, is built off-site. So all the waste that is generated from that construction is kind of contained within that site, the off-site, and can be reused and recycled better in that plant. And then it comes to your site as just big chunks and gets put down with limited waste. You could also look at resource recovery, so that would probably be water or energy. Obviously, just a more energy efficient house would reduce the energy used. You are allowed to recycle gray water or reuse gray water now. If you're not directly putting it below grade into kind of irrigating of trees or some type of outside irrigation, you do have to filter it because there are contaminants and stuff in the gray water. Gray water is stuff that comes from your dishwasher, washing machine, sinks, showers, everything basically a toilet, and depending on your kitchen sink is gray water. So there are lots of ways to incorporate waste reduction and waste recovery in design and construction. You want to put that as one of your goals up front so that you're designing the house with that in mind. So moving to the next one, what are the costs of retrofitting an existing home? So I kind of mentioned that before. It's somewhere between the $80,000 and $130,000. Unfortunately, in Alberta, there are no current rebates or incentives to do that. Hopefully those will come in the future, probably from the federal level at this point, because right now our current provincial government doesn't seem to have much interest in it. But there's a lot of conversation about the recovery plan from COVID, and there's a lot of people pushing so it becomes more of a green recovery plan. So there is hope, but yeah, $80,000 to $130,000, depending what all the scope is. Next question, how much insulation do you have to add to an existing home to reach passive house levels? So it all depends on the design, how much exterior wall you have compared to interior space. So the less articulated, the less complex, the more compact the house is, the less insulation you need. It also depends on how much solar heat gain you can get through your windows. But generally speaking, we say about R30 plus below the slab, R30 plus below grade in your foundation, R40 to R45 plus above grade, and R60 plus in your roof or your attic, and as best windows as you can get. But it all goes into the energy model, so the answer is all depends. But if you're looking for a passive house, your walls are probably going to be 12 to 18 inches thick, both above and below grade, and then a foot or two of insulation in your attic is kind of what is needed. So next question, how to create a cost-effective passive cooling while still having generous glazing for winter solar gains and views. So again, it all goes into the energy model. So the best way to do passive cooling or to keep your house cool is the insulation and the air tightness and the thermal bridge, because insulation works both ways. So that will keep the hot out of your house in the summer. The next is through permanent shading via overhangs or exterior shades on your south windows. That's the best way to keep the sun out of your house kind of during the July and August. June, July, August is when you want the sun to not be in your house. The problem with that is sometimes in April and May, you want some heat from the sun. So since the permanent overhang works on both sides of the solar equinox, June 20th, plus or minus. So if you're getting more sun in April, May, you're also gonna get some sun in your house in July, August, September. So that's a trade-off. The way it shows up in the passive house model is it gives you a percentage overheating. Overheating is when the design inside the house will be more than 25 degrees. So passive house says you should design your house at less than that. 10% is the maximum overheating. 5% is more recommended, and depending what other systems you use for more active cooling, you might want to design your house now for kind of 0% overheating so that you're not requiring more active cooling systems. If you can't just do it with overhangs, then another good way is exterior shades, or also deciduous trees work well. In the summer, the trees leaf out and will shade your house. In the winter, the trees drop their leaves, and then there's less blockage of the sun to come into your house. That's kind of the south windows. The east and west windows, you definitely want to use more trees because you can't use an overhang to shade them because the sun is rising and setting at the low angles. So overhangs don't work on east and west. And if you happen to have a view to the north, then you just put as much glass as the energy model allows you. Those north windows will never see the sun. They will always be energy loss. But if you have a great view to the north, then it's just you might justify putting some windows over there, and you just put them into the energy model. Another good, it's not quite passive, but fairly low cost cooling. I always recommend, if you're building new or have the ability to put some PEX pipes underneath the slab, you can use those via a simple hydronic system to preheat and pre-cool the air going into your HRV. So in the summer, you're using the coolness of the ground to pre-cool the air going into your HRV, and then it'll just through summer bypass go straight into your house, and then you can get some cooler air into your house. That's kind of free air conditioning. And then in the winter, you're using those same PEX pipes below the slab to preheat the air that's coming in, so the ERV and HRV doesn't have to work as hard, or an electric resistance heater doesn't have to work as hard to get that temperature of the incoming air up to somewhere that it doesn't freeze the ERV's core. You just have to be careful. You do want to have a temperature sensor. You don't want to use that too much in the winter so you actually freeze the ground below you. It could happen. It's not that likely to happen, but you want to have a temperature sensor to make sure that it doesn't happen. All right, so those are kind of the pre-entered questions. So let me pull up some of the other new questions. What is fiberboard? So wood fiberboard is basically, it's generally a byproduct. It's small pieces of wood that are superheated together so that the remaining lignins in the wood fibers themselves melt and kind of re-glue together. There is a little bit of additional acrylic or polymer glue that is used to bond them together, but it basically makes a panel of whatever thickness you want of small pieces of wood that are stuck together. They are vapor open, but they are stuck together, and they're very dimensionally stable. And you can occasionally have borate put in them so that they're more fire resistant and more resistant to animals and bugs eating them. But generally it's set up beside a mass timber plant. It's so that the small shavings from the mass timber production go to make the wood fiberboard. So that's one of the reasons why it is lower embodied carbon. Is it's generally a waste product of other wood products. What about SIPs and the insulation? SIPs and the insulation used in them. So a SIP is a structurally insulated panel. So it's some type of insulation with two structural, generally plywood, but sometimes it can be concrete cement or cement board on it. And the glue between the center insulation and the outside panels makes it a rigid panel. And then when you put them up in kind of 4x8 sheets or whatever size the panels are, you then use dimensional lumber the connections to screw it all together. So most often SIPs use EPS foam, and EPS foam has a fairly low embodied carbon, has a fairly good R value per inch, and other good products or other good properties. The problem you have to watch out for SIPs is those connections. They're called splines. So every 4 feet, if they're 4x8 panels, you have what can be a continuous 2x4 or 2x8 or however thick the SIPs are, times 2 sometimes, piece of wood. So that's a thermal bridge. So the better iteration of a SIP would be that that spline has is split up. If maybe you have an 8-inch panel, you have, or a 12-inch thick panel, you only have maybe a 2x2 spline on the outside, a 2x2 spline on the inside, and some foam on the inside. You just want to find a way to reduce the thermal bridging of the splines at the joints. Otherwise, SIPs are an effective option. Again, I would prefer if they are vapor open, and you can get vapor open SIPs, but they are an option. It's just mitigating that thermal bridge from the splines that I have found difficult the few times I have looked at them. But again, there's always new products coming out, and if you don't find what you want, keep asking, and the new products hopefully will change. Are there prefabricated new building methods? Right now in Alberta, there's not a lot of prefabricated passive house builders. There's 1 or 2 in just over the Rockies into BC. There is Collective Carpentry, which prefabricate walls, and also Thomas Stitch imports from Europe mass timber and wood fiberboard, kind of as a prefabricated kit. It comes with windows as well, so it goes together in big chunks. There are some modular home builders or manufactured home builders in Alberta that have dabbled in the prefabrication of passive house level buildings. So again, if we keep asking them to do that, then they can. Again, it's not totally changing your system. It's just looking at thicker insulation, looking at better air tightness, changing some other details. So any manufactured home or mobile home builder could make a passive house style home. It's just having the demand there to get them to do it. In the States, there are a number of them doing it. Shipping them up to Canada gets a bit costly, but it is an option. There's some, I think, as close as Montana. But yes, prefabrication is an option, and it's just takes a bit more work to look into it. Prefabricating the wall panels is an easier option, and there are a few people doing that in BC right now. So next question, what is the average cost differential for the average homeowner to push closer to passive house? So basically, what's the cost upcharge to get to passive house? So that depends where you are. If you're in, say, Vancouver, which is kind of one of the best ones, they've increased the code, so the code minimum is higher, and they've given some other incentives to go to passive house. So in Vancouver right now, the upcharge to go to passive house is 0 to 3%. We don't live there, so in Alberta right now, we say it's between 5 and 15% to get to passive house. And that's a big range, but that depends on how focused you are. If you put passive house as one of your requirements from the beginning, and you allow, say, the size of the house, you allow some of the architectural features that might be there otherwise to work within a budget, then you can reduce that cost increase. It's very difficult to take any design and make it a passive house. It's better to start with passive house as a requirement from the beginning and work from there. If you're doing a custom home, you should be able to tell your builder, these are my requirements, passive house is one of them, this is my budget, build me a house. So that there is zero upcharge because you will get a house with your requirements for that budget. But again, it's 5 to 15% if you're using a builder that's done it, that isn't his first build, or a designer that isn't his first build, so that he's got some efficiencies and he's made all the mistakes and figured out how to optimize it. Then you can get down closer to the 5%. If it's your first time you're doing a self-build and maybe you can't optimize the design, the layout, the compactness, the solar orientation, then you might be going closer to 15%. The other side of that question, though, is remember you're getting your utility savings. So very few people buy houses for cash. Most people buy it on a mortgage. So when you're buying a mortgage, really what's important to you is, what is my monthly mortgage fee? What is my monthly utility costs? So your mortgage might go up by a few $100s, but because you're in a passive house and you have 90% less space heating costs and 40 to 60% overall utility savings, your utility bill is less. So for example, in my house, I had a very small mortgage anyways, but in my house, I save about $220 a month on my utility bills compared to building my house to code minimum. So you can do the math on it. You can do a graph to say, this is how much more, this is the increase in the mortgage costs monthly, and this is the estimated decreased utility bills. And the perfect passive house is where they even out. They might be a bit higher, they might be a bit less, depending on your utilities, but it's not just thinking about the upfront cost, it's adding in with the ongoing savings. And that savings is for the next 25, 50, you build a passive house to last 50 to 100 years. So those utility savings are there much longer than your 25-year mortgage. And you get all the comfort and health benefits from a passive house from the beginning. So that's kind of, there is a cost up front, but you put that on the mortgage, and there is ways to optimize it. Next one, what is the most common thermal bridges within a typical house? So the most common thermal bridges in a typical house are your studs. If you don't have continuous exterior insulation, which is insulation that covers everything on the outside, you will have thermal bridges from a steel, well, hopefully a wood stud every 16 inches, 24 inches on center, plus your bottom and your top plates. So those are your most common thermal bridges. The next most common thermal bridge would be your rim joist. So your rim joist is where all of the joists from the slabs or the floors come in, and they need a large piece of wood to hold them. And that large piece of wood, again, is a thermal bridge. The TGIs that come from the floor aren't that big of a thermal bridge because TGIs, there's just not much wood there, but that rim joist is a fairly good thermal bridge. And that whole area is hard to insulate. So if you can move that rim joist in as much as you can and get some continuous insulation on the outside, that's how you mitigate that one. The other thermal bridge, it's what's called the geometric thermal bridge, is a corner. Anytime you have a corner, you will lose more energy in that corner than a flat pane of wall. In an infinite wall, you have 1.5 inches or 1 square inch of inside wall has 1 square inch of outside wall. So the ratio of inside area to outside area sucking heat out is the same, 1-to-1. If you put that at a corner, so if you have half of that square inch on one side of the corner, half of it on the other side of the corner, even with a 2x4 wall, your outside, you have kind of at least 4 and 4, you kind of have 8 inches, 8 square inches of exterior wall sucking the heat out. And also at most corners, you have 2 or 3 or sometimes even 4 studs in that corner, so it's hard to get insulation there. So corners are always thermal bridges because there's more outside air, outside space sucking the heat out, and there's less insulation. So again, 4 corners would be the best. Very compact design. Every time you add another corner, you're adding more details or more energy loss. The last kind of next place for thermal bridging would be, actually the biggest thermal bridge right now, since we don't have to insulate below grade, is your basement slab. The ground is about 6 degrees, which is the average annual temperature, 2 meters down. So your ground, if you just have 6 or 4 or 8 inches of concrete sitting on 6 degrees, that concrete is going to want to be 6 degrees because the concrete is a fairly good transmitter. It's more of a conductor as opposed to an insulator of heat. So getting some insulation, even 2 inches, passive house normally has 8 of insulation below that slab, will get rid of that large thermal bridge. If you want your basement to be occupied space, if you want to use that space to live, you want the floor not to be cold, insulate it. Same thing with your foundation walls. Try to get a little bit of insulation on the outside of the foundation walls. Code only requires you to go, I believe, 2 feet down. You should go the whole way down, continuous insulation all the way around your footings. The last thermal bridge, again, is your transitions from walls to roof. You have more wood there. If you don't do what's called a raised heel or energy heel adduct, that's where you raise the adduct rafters so that the amount of insulation that would be continuous doesn't get pinched at the eaves, at the corners. So you do a raised heel, high heel energy truss, and then you can make that insulation continuous all the way around, and then you don't have that thermal bridge at the corner. So those are the main ones. There are a lot more, but those are kind of the main ones that you try to mitigate. Any mistakes while building your home or in general? So the biggest, like my house is performing to the design. Unfortunately, I designed it for 8% overheating, which is still less than the maximum of 10%, but with our climate and the climate getting warmer and the potential to have smoke and forest fires, 8% is too much overheating. So I have mitigated that by putting on some exterior shades. I just use basically a screen, and I put some 80% sunshade fabric on that. It looks kind of like bus wrap, so I can still see out, but it blocks 80% of the sun's heat so that less heat is entering my house, because that 8% overheating was too much. That's why future houses I'm designing down more to the 0 to 5% overheating. Another lesson that I've learned is, especially if you're doing multifamily or secondary suite below, is that interior noise is a bigger concern, because passive houses are so quiet, they're so well insulated, they're so well air sealed, there's no furnace, there's no blower motor, there's basically zero background noise. So all the interior noise gets amplified. So the sound transfer between the secondary suite and my floor is a bit more than I wanted. I have 2-inch concrete as thermal mass, then I have acoustical isolator below the concrete, then I have Roxel in the TGIs. The part that I missed as far as sound transfer from above to below is I didn't use resilient or acoustical isolator pucks, rubber isolators, or resilient track on the drywall ceiling, and I only put 1 layer drywall. So if you are doing any type of party walls or multifamily, just worry more about sound transfer. I also put Roxel in between the interior walls for some thermal mass and some sound attenuation between rooms, so it helps keep the sound in the rooms that it's created. The other big thing I learned is that if you are doing a concrete topping in a passive house, because it's so airtight, and if you're doing the topping when your airtightness layer is complete, make sure you open your windows. Concrete doesn't dry, but on the initial set, some of that bleed water does have to come out through evaporation. So unfortunately, my windows were closed because I didn't know this. So what the finisher then has to do is overwork the slab to try to get it to get the bleed water out. And because of that, I have a little bit of spalling which is just little flakes of concrete coming off of my floor. So if you're doing that, make sure you open your windows or just do the concrete topping when you don't have the air tightness. So you let that concrete cure normally, and then that concrete topping will be an excellent, durable, and relatively low cost finish. Any other building homes? Yeah, so it's kind of the main lessons learned. Still learning more. Am I aware of any SIPs made with wood fiber instead of foam? No, I am not. It would be tough to get all the adherence between them. The way I have, instead of a SIP, it would just be mass timber with wood fiber board on the outside. But no, I don't know of any SIPs with wood fiber in them. However, out east, there are SIPs made of straw bales. They're not actually a SIP, they're more of a prefabricated panel. So there is more of a wood frame around it, but it's insulated with straw. And straw, if you remember, is the lowest embodied carbon. It's a negative embodied carbon because straw is the non-nutritional bottom stalk of wheat. So it's basically a waste product. You can kind of use it for animal bedding, but generally it's an agricultural waste product. So it's very cheap. And that's why it's got such low embodied carbon. So that's out east. Hopefully we can move it here at some point, but there are starting to be straw prefabricated panels. Sorry about that. Next question. For a building project, would it be important that all trades involved had Passive House training certification, or are there just key trades that you'd want to ensure have Passive House training? So preferably, no, they don't all have to be trained. That's the preference. They all have to have buy-in, or they all have to at least be aware of it. The biggest trades are your envelope and your air sealing, your window installer. Those actually are all available that can make the standard. But you need to make sure your general contractor, your electrical and plumber are also aware of it. If you don't have what's called a mechanical installation cavity, which is basically another stud that's inside your vapor barrier that allows them to run without penetrating the vapor barrier, you just need to set up some type of system. It's not really air sealing police or Passive House police. You just need to tell them that if they drill a hole in the envelope, or if they penetrate the vapor barrier, please tell us. You won't get in trouble. I just need to know about it so I can fix it and tape it correctly so it's not an air leak. The other thing you need to do is you do a blower door test while your vapor barrier and hopefully outdoor weather resistant barrier is accessible. So before drywall is up, that way you can find all the leaks that maybe they didn't tell you about and fix them before they get covered up. But yeah, you need buy-in from everyone. They don't all need to be trained. And we've found that once they kind of see it, go through it once or twice, obviously the first time they're going to be a bit more scared and maybe put a premium on it. Once they've done it and learned all the details, it isn't that much different than what they've done before. So it's not the end of the world. They won't run away. So just make sure it's a priority up front. Make sure your general contractor believes in it, or you at least put in his contract some air tightness requirements, a thermal imaging camera so you can see the insulation, enough requirements that he is going to do it. But yeah, they call it integrated design, is where you bring them all in from the beginning. You get buy-in from everyone from the beginning. That's kind of the main thing. But not everyone. Like the finished trades, the drywaller, the painter really shouldn't be touching anything that's in the vapor barrier. So they might not even notice it's different. Well, they will notice if you're in the winter because it's warm and comfortable inside the house and it's not cold and you don't have to do much winter heat. So that's another nice thing. Do I recommend radiant in-floor as a heat source? Generally, no. The reason I don't is again, you're in a passive house, you're reducing your space heating demand and cooling demand by 90%. So in my house, my peak demand is about 4,000 or 5,000 watts, which is pretty small compared to, say, a furnace that's like 60,000 watts. Or sorry, 60,000 BTUs, which is like 20 or 30,000 watts. So because it's so low, and if you are in the winter relying on or allowing the sun's heat to come in and you have good access to the sun's heat, you want a system that can turn on and turn off quickly, because if it's a cloudy day and it's cold, you might need the heat. But then if the clouds go away and the sun comes up, the sun will come and heat your house very quickly. So a radiant system is a very slow to react, which is good for a standard house because once it's warm, it stays warm. But in a passive house, it might have warmed up, and if the radiant floor, if the floor is the main floor that the sun hits, the radiant floor has heated up that floor, which could be a thermal mass, so the sun's heat can't be absorbed into it, so the sun will just heat up the airspace quicker. So most times radiant inflow is too slow to react, is more costly than other options, and again, is just provides too much heat than you need. Most radiant floors need to run at kind of 30 or 40 degrees, so you get that warm feeling on your toes, but it will overheat your house too quickly. So you only really want heat that can come on at maybe 25 degrees or maybe 30 degrees for a few minutes, bring up the temperature as long as it needs to bring up temperature, and then turn off completely. Do you know how many passive house projects are currently under construction in Alberta? That's an interesting one. I am just finishing one. There's another one. And with passive house, I'm going to expand it a bit more to certified and uncertified passive houses, and even ones that are kind of using passive house in the background as the energy model, but maybe not going the full certification. It's still probably 10 to 20. If you increase that even more to maybe the net zero buildings, you might be in the 100 mark. Edmonton is building a lot more than Calgary. Calgary's still a little slower to adapt. It's a growing number, but it's still a small number, unfortunately. Next question, how do I keep up to date with info on new technology and products? So there's a few websites that I like to go to. Green Building Advisor is an excellent one for all things green. Passive House Accelerator is another very good one for passive house specific stuff, but they have lots of products as well. There's a North American Passive House Network, which is a good website to go to. There's Passive House International. They have a whole Passipedia, which is basically a website of all of their components. If you sign up with Passive House International for the newsletters, they send out component newsletters kind of monthly, listing all of the newly Passive House certified products. And just LinkedIn is also a good way to stay up to date. Follow like Canadian Home Builders Association, the Net Zero, follow the lead in the Canadian Green Building Council. Or Passive House Alberta will have a hopefully increasing number of stuff. But yeah, kind of Green Building Advisor, Passive House Accelerator are the main ones that I use. What is my preferred exterior insulation material and why? My preferred one, actually, I guess there's two. My preferred one, if you're doing a deep double stud wall, would be blown cellulose. So blown cellulose, again, has a very low embodied carbon. It's carbon negative because it's just recycled newspaper. We have an excellent installer in Calgary. We have some good installers in Edmonton and other areas. It's fabricated in a plant in Edmonton, so the transportation cost is low. It is wood or newspaper, but it has borate in it, which reduces its fire spread rating, and mice and animals can't eat it because it's kind of, they just don't like to eat it. And it's low cost. It's probably the lowest cost insulation option out there, so that's why I like dense packed blown cellulose. both in the walls, and then loose blown cellulose in the attic. Below grade, I like EPS insulation because below grade, it's going to get wet. So I don't really want a wood fiber, even a Roxol. I don't really like below grade because it loses all its R value when it gets wet. And definitely not a wood fiber either below grade. So EPS foam, again, it's probably the second lowest cost. It has a lowish embodied carbon, still positive, but lowish. It can be recycled. There's no off-gassing. The blowing agent that makes EPS foam is pentane, but it's all off-gassed in the plant. The air bubbles that make up the matrix end up having air and not a chemical in them. So the off-gassing happens in the plant, and it's actually recycle a lot of that pentane. So there's no off-gassing in your site. So the R value is stable. So below grade, EPS foam, above grade, dense packed blown cellulose if it's a double stud wall. If you're doing kind of a renovation or a split wall where you have the structure and then exterior insulation on the outside of it, I really like wood fiberboard. I'd like it if I didn't have to import it from the States. Import it from Europe, which pushes the price up. So above grade, I do like Roxol, and EPS foam, again, is very cost effective. Solar Homes, Peter Darlington uses EPS foam. It costs $15 per square foot of wall to get 6 inches, which is about R24. It costs $20 per square foot of wall to put 12 inches of insulation on it, which is about R40. Because the way he installs it, whether he's installing 6 inches or 12 inches, the labor is the same. It's just the material cost difference. So kind of whatever material using as continuous exterior insulation, get as thick as one you can in one go, because then you're not adding any labor. Once you have to add 2 layers of a material, then you have twice the labor to stick it on the wall. So yeah, so I don't have one top one. I like them all. It depends on the location. It depends on kind of fire code. If I was building in Canmore, I would probably lean towards Roxol above grade with like a hardy plank siding on it just to get that increased fire resistance. But there is some types of fire rated stuccos and EFISs as well. But dense packed cellulose is also the lowest cost option. Answer, lots of answers on that one. Can you add insulation on top of the basement floor? Yes, you can. So in a renovation, obviously it's easy enough to put insulation on the outside. If you can dig down, you can get insulation on the outside of the foundation walls, but you never get insulation underneath the slab. So quite often you transition from insulation on the exterior to insulation on the interior in your basement. And then you would put some type of foam on top of your concrete. You want to make sure that you deal with any water issues first, make sure your foundation is not leaking water, and then you can put EPS foam if you have any water concerns. If you're certain you're never going to get water down there, you can use polyiso because polyiso has a higher R value per inch. It's about R6 instead of R4 for EPS foam. And polyiso, the downside of polyiso is when it gets really cold, the R value actually drops. But since, again, it's staying at about 6 degrees or warmer in your basement, polyiso in your basement is a good option. And then you're only losing maybe 2 inches of headspace and you can get R12. It's normally used in commercial roofs, so it is readily available, but it doesn't like getting wet. If you have any concerns with that, you can use EPS foam. One of the other builders that or products that I really like is SI Construction. They use EPS foam and steel studs on the inside and enough EPS foam on the outside to get rid of the large thermal bridging effect from the steel studs. They can actually make a foundation, below grade foundation wall with their panels. They also have a foundation system for the slab where they use EPS foam, their steel stud track on the inside, and then a layer of plywood, and that basically removes all the concrete in your slab. They could also just provide you with foam for below grade and insulating your basement, another option, another product is called Quick Therm. They have a few products. One of them is their kind of basement insulation. They have wood strips on the inside of the foam and a vapor closed layer or membrane on either side of the foam. So if you stick that kind of to your concrete foundation wall, it has tongue and groove joints, and then you tape the joint, it gets an airtight seal. Those wood strapping allows you to either do another insulation cavity, or you could router it out to put your electrical, but then you have something to attach drywall to it, and then you could do other type of foam on the basement. Again, you just want to watch where your vapor barrier is. The vapor barrier needs to be on the inside. So if you are insulating the inside of your basement, you have to make sure your vapor barrier is on the inside, not on the outside. So yes, that's the way you insulate your basements. You can put foam coming up. So hopefully you have 8'6" or 9 feet basements. Otherwise, you're starting to cut into your ceiling height. But yes, putting foam on your basement slab in a renovation to get it warmer is an excellent idea. And same with the walls. Do you consider that the houses from 10 years ago or more could be adopted or redesigned to a passive house? Yes, so, well, it depends on the design. Unfortunately, recently and still kind of ongoing, to add, developers really like to add articulation, especially on a second floor. They bump out like an 8-foot by 1-foot section because building codes allow them to do that to get a little bit extra square footage in their house, because houses are still sold via square footage. So it depends how articulated the house is. The more articulation it is, the more difficult it is. But just with any house, putting 6 inches of insulation on the outside of it, doing some air tightness, putting some more insulation into the attic will get you a lot further down the road to becoming passive house. You might not get all the way to certified, but you will get improved air quality, you will get improved comfort, and you will get reduced energy bills. So any house can be done. The less complex, the less articulation, the simpler it is, the easier it is. But any house can have it done.
Okay, that's great. Thank you, Frank,
So
for
I
answering
think I
all
ran
those
through
amazing
all my
questions.
questions.
I think you did. I think you got through all of the questions. It looked like we had exactly the right amount of questions to fill the time. So that's amazing. Just before we wrap up, I'd just like to share with everyone. So when you exit the webinar today, a survey is going to pop up on your screen, and I would really appreciate it if everyone could just take 5 minutes out of their day just to complete the survey for us. We've been working at the Biosphere with Dr. Jill Budefeld, a postdoctoral fellow at the University of Alberta, and she's helping us to analyze the effectiveness of these webinars. We really want to prove that we're helping educate people, and she is going to allow us to show that to future funders and opportunities. So I really would encourage everyone to participate in the survey, and if you do and leave your email at the end, you'll be entered into a competition with a chance to win a portable Anchor solar charger. So thank you everyone in advance for participating in our survey. And finally, next week, we have Tyler Hermansen from 4 Elements Integrated Design, who's going to be taking you on a guided tour of green building programs in Canada, specifically for homes and residential buildings. So please sign up and stay tuned for that. Also, don't forget to check out our online trade showcase, in which Solar Homes, as Frank mentioned, is a starring part. It's now online and available for your navigation. Thank you very much to everyone for joining us today, and special thanks to Frank for providing his wealth of knowledge. As he mentioned, if anyone has any follow-up questions, feel free to email education@passivehouse Alberta. I'll pop that into the chat for everyone before we leave, so you can copy that out. Thank you everyone for coming, and I hope to see you all next week.
Yep, thank you all.